Hi everyone, this is Jongwen. Today is June 27, 2019. I will record this video to briefly talk about what have been done in past week. So here is the highlights. Firstly, I keep working on the workflow Executor Local version in the past week and debugging all the issues, and currently I have two versions Executor available, and both of them has been tested on the calcCovMatrix workflow, and both of them output correct answers. The first version is to have each task run in individual threads, and the second version is have every local schedule run in individual threads. Because of current data view that only use a file-based implementation, so both local versions will save all intermediate result in txt file and not in the object at this moment. Maybe we can implement it later with some relevant changing some classes. So let me briefly go through the code I have here. In the local version 1, which extends task in the thread class, that means each task run in individual threads. Here, in the constructor, we take the task dir, leave dir, and global schedule as inputs. And in the execute method of this workflow execute class, we basically do three things. And the first thing is to put all the tasks in the task array, and second thing is to save all the tasks and their children's relationship in the relationship map, and the third thing is to start all the tasks at the same time. So if we take a look at the task run class, it extends the thread class, and for every task we have its own lock and condition, and it has few methods to take care of, like the parent finished and how to notify the children. And we also have two methods, as we talked in last video, to take care of the mapping input port and file, and mapping the output port and file to corresponding ports in task. So here we have an execute method for the task run that only load the task class, task name class, and also because it will execute after the mapping the input port and output port, so the task will be run just fine. So here is a run method that's override the thread class. So we can see here every task will periodically check whether it's ready to execute or not, and then if it is, we will map the input port and output port to its corresponding port index, and then to execute the method above, and then we will synchronize to decrease the total number until it is 0, and we will print the task execution time. So we can give it a run. So this is called local version 1. If we give it a run, we can see from the console it says execution time is 1:18, so that means it has been successfully executed. If we scroll a little bit up, after it prints out the global schedule, we can see all the threads are starting at the same time. So there are 17 threads starting at the same time. If we refresh the data view repository, we can see all the intermediate outputs, and the final output has been saved in this repository. This is a final output, and we can see it's correctly calculated the covariance matrix for the input matrix. So this is the first version. When we can take a look at the second version briefly as well. So in the second version, it's quite similar to the first one, except it has another class called the localSchedule run, because we run every local schedule in individual threads. So we have individual lock and condition for every local schedule. And we also have a few methods to take care of the task completed and to notify the children. And here is a run method that overrides the thread class. In the run method, we loop through all the tasks in the local schedule, and then to periodically check whether they're ready or not. So that's sequentially check everyone and execute everyone, and then we will load the class, and after we map the input port and output port, we will execute it. So that's similar to last one, and then we will output we will get the total amount total execution time, and then it's completed. So we can also give it a run here, so we save it as a local 2. So we can see here the execution time is 169. It has been successfully executed because we're running the task in sequentially in a local schedule. So you can see the thread running is separate. It's not running totally together, because it in our workflow, calculate covariance workflow, it only have one local schedule, so that we only use one thread actually throughout all the execution. If we just debug a little bit, we can see it more clear. Here in the global schedule, we only have one local schedule, so that means we only have one thread throughout the execution. So I think this is overall what I will talk about today, and thank you for your time. Hope you will enjoy this video, and until next time, happy coding.